Hello, grade 10. As we said today in the class, we're going to explain systems of inequalities of two equations where we have and or. As we said, and is the common between the solution, or is everything. We're going to see graphically what do we mean by that. Let us take the first graph. These are, you have 8 different graphs you may get. Graph 1, suppose you have x less than a and x bigger or equal to b. As you can see, for example, x less than 5 and x bigger or equal to 7. Do you have anything in common? As you can see, nothing in common because we're no intersection between the two, so it's an empty set. This is the abbreviation of the empty set. If you want or is everything. Suppose you're moving from minus infinity till plus infinity. You take all values from minus infinity till a without taking the boundary a. Then you jump from b, you take b as a boundary till infinity. The second graph, the same story, but here is closed, here is open. Same story, it's empty, you don't have anything in common. And for x belong, it's closed at A and open at B. Another kind of curve, suppose you're going to get x bigger or equal to A or x bigger than B. And A is smaller than B, so you have this picture. So the common, as you can see here, the common between the two, here it is common. So the common will be from B till infinity. Because B is not included here, so it must be open. So it's open B till infinity because B exists in the first line, but it is not in the second, so we don't take it, so we open it. However, in the second one, concerning or, so you must put everything. So this line is inside the first one. So we take from A till infinity and A is closed. Or it means everything. So this line here plus that line, but that line is inside that line. So I start from A till infinity close. Suppose you have this one, x less than A or equal and x less than B. A is included, B not included. Come in, the common is here. From minus infinity till A close, concerning or everything till where? Till B, since this part of the line is here. So no need to count it twice because it's already in. So from minus infinity till B open. Another graph 5, suppose you have this graph up equal to A, bigger or equal to A, and less than B such that B bigger than A. So if you want to search for the common, here the common is between A and B. So here A is closed because it's in the first but in the second. B is open because it's in the first line but not in the second, it's open. However, or is everything from here till here and here till here, so all the set of real line, so from minus infinity till infinity. Remains these kinds of question where the answer, for example, for both system is the same number, less or equal to A and bigger than A. So it's less than number, for example, x less than 5, x less or equal to 5, and x bigger than 5. So nothing in common because less than or equal to 5, bigger than 5, nothing in common, empty. And concerning or is everything. Why? Because you move from minus infinity till A is in the first, then you move from A till infinity. A is not in the second, but because it's in the first, so I take everything, so it will be R. The last two graphs, suppose both are closed, like number 6. So here at the same time, A is in the first, A in the second, we take and as a common, or will be everything. Suppose both are open, so we don't have anything in common. Concerning or will be everything except the point A because A is not in the first nor in the second. Let us take 3 examples. Suppose you want to solve that one, you want to find and on or and write in interval form. You have 3x. If you take minus 3 bigger than minus 3x minus 1, you put minus 3x on that side, minus 3 to the other side, you're going to get x bigger than 2 over 3. And here you take minus 7 to the other side, 16. Because coefficient of x is negative, bigger or equal will be less or equal, 16 over minus 2 minus 8. Less or equal minus 8, bigger than 2 over 3. So as we said up, nothing in common. So we don't have anything in common, so empty set. However, or is everything. So from minus infinity till A close, union 2 over 3 open till infinity. Another example, suppose you have this one. Let me start by the first equation here. Since you have 4 and 2 here, I multiply all by 4 to cancel denominator. 4 over 2, it will be 2 into x minus half. And 4 divided by 2, it will be 2. 4 divided by 4 is 1. If you expand, you're going to get 2x less than 4 and x less than 2. Similarly, here I multiply all by 3 because I have 7 over 3. I don't look inside the parentheses now. 3 times 2 is 6. You have this expression, you copy it again. 3 over 3 cancel, remains 7. So 6 times 5, 30 over 2 is 15x. 6 divided by 3 is 2 bigger or equal to 7. It will lead us, if you take the numbers to the other side, x bigger or equal than 3 over 5. 3 over 5 is less than 2. You want bigger or equal. And for x, you want it less than 2. So the common here between the two is from 3 over 5 included till 2 open. And or is everything. These lines are overlapping. So from minus infinity till plus infinity. The last example is this one. If you multiply by 2 to cancel the denominator, you're going to get 4x minus 1 less than minus 9x less than minus 2. If you take this one, sorry, here, let me correct it. It must be over 10. There is a mistake. Okay. So if you multiply all by 10, 30 over 5 is 6 into x minus 2. 10 over 2 is 5. 10 and 10 cancel, minus 19. If you expand and put the numbers to the other side, you're going to get x bigger or equal to minus 2. So here we have two numbers the same. The last graphs, last three graphs. You want to put x less than minus 2. So here there is, I want it less than minus 2. So here it must be open. Here must be fill. It's the same. Here open up, down fill. So because one open, one fill, x belong to the empty. And because here one of them is filled, so or will be everything from minus infinity till minus 2. Then from minus 2 till infinity. We pick minus 2 because it is included in one of them, so it will be R. Guys, I want you for tomorrow to do the homework and see you tomorrow in the class. Do that problem, the 3 problems tomorrow, and see you tomorrow. Good luck.